Properties of parabolas. Write down the first example. Y equals negative 1/2 x squared plus 2. And this is what you're going to have to do to graph these. This whole section is about graphing parabolas. You should be able to look at that and tell the direction it opens. Opens down because your A value is negative. Yes?
Is that a V right there?
That's V for vertex. The first thing we should be able to tell is the vertex. Who knows standard form? Who remembers standard form? What is standard form?
S B Y equals C.
AX squared plus BX plus C. Okay. Notice here in this example there's no B value. Okay. Those are the easiest ones to graph. If there's no B value, you got AX squared plus C. Your vertex in that case is always 0, C. Alright, so the x coordinate of the vertex is 0. The y coordinate of the vertex is whatever your C value is. That's only if there is no B value. The next example we're going to do, there is a B value. I'll show you how to find it there. But we should be able to look at these and tell that the vertex is 0, 2. When you do your table of values, put the vertex in the middle. Okay? 0, 2. Now, you choose any points you want for x. Okay? What you want to do is pick 2 points on the right of the vertex, 2 points on the left of the vertex. Notice I chose 2 and 4 here, and negative 2 and negative 4, because that way I won't get a fraction in my answer. You could have chosen 1 and 2, but you would have gotten a fraction when you plugged in 1, which is fine if you're okay working with fractions. Yes?
It's the AOS thing.
I may get to that in a minute. Here, 2 and negative 2 are corresponding points. We talked about corresponding points in the last section. Alright? You want to pick corresponding points. It makes life a lot easier. Because for corresponding points, the y values have to be the same. So you cut your work in half if you pick corresponding points. But again, if you don't want to, if you want to just pick any 2 points to the right, any 2 points to the left, that's up to you. Okay? But once I plug in 2 for x, what's 2 squared? 4. What's negative half of 4?
Negative 2.
Negative 2 plus 2 is 0. Without doing any work for the negative 2, you don't have to plug the negative 2 in. You should know it's 0 also, because these are corresponding points. 4 and negative 4 have to have the same y value, too, because they are corresponding points.
The middle
Corresponding points mean there's the same distance from the vertex.
The middle point is the vertex, right?
Yes, so always put your vertex
Wait,
on.
how do you find the vertex again?
If there's no B value, which there's not, your vertex is always 0, C. Your C value is here. Alright? We talked about the axis of symmetry last week. The axis of symmetry is always the same as the x coordinate of the vertex. So since the x coordinate of the vertex is 0 in this case, the axis of symmetry has to be x equals 0. That's right here. Okay? That's the one that cuts it in half, makes it a mirror image. Alright, then all you do is plot the points. Start with the vertex, 0, 2, negative 2, 0, 2, 0, negative 4, negative 6, 4, 6, connect them. And that's it. Alright, so those should be the easy ones when there's not a B value. Is everybody okay with those? Alright, next example. Alright, here's another one. Without a B value, you should be able to look at that and tell that the vertex is 0, negative 4. Correct? No B value. Axis of symmetry, you should be able to tell, once you get your vertex, is x equals 0. Always the same as the x coordinate of the vertex. Table of values, put the vertex in the middle, and I chose the points 1 and negative 1 correspond with each other on opposite sides. 2 and negative 2 correspond with each other on opposite sides. Yeah.
So is it flipped because it's a negative?
What do you mean? The x values?
The parabolas upside down, U instead of like a R.
Well, the last one, the one we did before, opened down because the A value was negative. If A is negative, it opens down.
Oh.
But again, you don't even really have to worry about that. In this case, A is positive, so it has to open up. But once you do your table of values, I mean, it'll open in the correct direction. Okay? Does everybody understand how I got the Y values there?
Not really.
Okay? If you plug 1 in for X, what's 1 squared? 1 times 2? 2 minus 4?
Negative
Negative 2. So Y has to be negative 2 in both of these cases.
2. What would you plug in for X?
1.
Okay.
When you plug in 2, 2 squared is 4, times 2 is 8, minus 4 is 4. So 4 has to be 4 in both of these cases.
Let's pick any number, can you?
Yeah, you can pick any X value you want. I'll probably end up giving you the table to use.
Okay.
So you have to come up with the Y values.
Oh,
Plot
but we
these
pick those
points.
numbers?
Graph. Okay? Everybody got that one now? All right, next example. All right. Now, if there is a B value, there's a formula to finding the x-coordinate of the vertex. So write all this down. Graph y equals x squared minus 2x minus 3, label the vertex and axis of symmetry. And then to find the x-coordinate of the vertex, you had to use this formula, negative b over 2a. All right, so in this case, to find the x-coordinate of the vertex, what's your b value up here?
Be 3, negative 3.
Negative what?
3.
Negative 2. Just negative 2. All right, so what is negative 2? Positive 2. So that's where we get that 2 from. Divided by 2 times a, what's your a value? 1. What's 2 times 1? 2. What's 2 divided by 2? 1. So the x-coordinate of the vertex is 1. Once you know that, you know your axis of symmetry is x equals 1.
Where do you get the problem negative b over 2a?
That's the formula for finding the x-coordinate of the vertex. I will probably give that to you. Yes, every time. To find the y-coordinate of the vertex, plug 1, since I got 1 from the x-coordinate, plug 1 in for x and solve for y. So you plug in whatever you got for the x-coordinate of the vertex into the original problem and solve for y. So what's 1 squared minus 2 times 1 minus 3?
Negative 4.
Negative 4. So the vertex is 1, negative 4. Okay? And the points I would pick that correspond with each other, they got to be the same distance from the vertex. 2 and 0 correspond with each other. Correct? Because they're both 1 unit from the vertex. 3 and negative 1 correspond with each other. So when you plug 0 in, that's the easiest one to plug in. When you plug 0 in to x, you get negative 3. So that means that you have to get negative 3 here. When you plug 3 in, 3 squared is 9, minus 6 minus 3 is 0. So that means I got to get 0 here also. Plot the points and you're done. We're okay with plotting points, correct?
Yes.
Okay. Question before we move on?
Yeah, I have a question.
Okay, yeah.
On the x and y columns, why did you pick, never mind.
Got it? All right, next example. Okay, same type of problem. You should be able to look at this one and tell that the graph opens down because A is negative. Alright.
Hold on, what's that standard form again?
AX squared plus BX plus C. Alright, so there is a B value. We have to use our formula negative B, which is negative 4, over 2 times negative 1 is negative 2. So the x coordinate of the vertex is positive 2, which tells you that the axis of symmetry is x equals 2. When you plug 2 back in for x, you end up with 6. So my vertex is 2, 6. Corresponding points I choose for x are 3 and 1, and 4 and 0, and that's what I should get from my table. Plot the points and draw your graph.
Do you know when it opens like sideways?
We won't do sideways or left and right now, just up and down. But left and right would be, instead of y equals x squared, it'd be x equals y squared. We'll do that later on. Okay. All right. And the last example, everybody got that one?
I do not.
Okay. Well, while you're finishing that one, let me go ahead and start on the next example. If the graph, you know how to tell whether the graph opens up and down, right?
It is negative.
If it's negative, if A is negative, then which way does the graph open?
Down.
Down. If A is positive, opens up. So where's your vertex if the graph opens down? It's at the top of the curve, right? So you are looking for a maximum value. Since it's at the top, it has to be the maximum value. If it's opening up, the vertex is at the bottom, so what would you be looking for? Minimum value. Yes.
When you plug in 2 from the x, how'd you get 6? Because I keep getting like 10.
Well, you do, here you gotta be careful. Orders of operations, you gotta do 2 squared first.
Yeah, I know.
So that's 4, and then take the negative. So that's negative 4. Plus 8 is 4, plus 2 is 6. Right here. Okay. Alright, so does that make sense? If it opens down, we're looking for a maximum. If it opens up, we're looking for a minimum. And all you're looking for is the y value. So in this case, you would be looking for a maximum point. Your maximum value would be positive 6. You look for the y coordinate of the vertex. Right? So graph the function, we know how to do that. Find the minimum value. They tell you that you're looking for the minimum value, so you know the graph opens up. We should know that anyway because A is positive. So all you have to do is find the vertex. So we still find the x coordinate, negative b over 2a. Get negative 2, plug negative 2 back in. You end up with negative 9 as the y coordinate of the vertex, which is also the minimum value of the function. You only want the y coordinate. Yeah.
So the minimum and the maximum values are just the vertex.
The y coordinate of the vertex only. Don't give me the whole vertex. It's just looking for the y coordinate. Does that make sense?